It starts with an idea so bold it sounds insane. What if we could use nuclear bombs to fix the planet? You're not dreaming. This was once a real proposal. Scientists and generals imagined carving new harbors with atomic blasts, sealing volcanoes with fire, even stopping hurricanes by detonating bombs inside their eyes. They believed the same force that could erase a city might also reshape Earth itself. Picture it: a mushroom cloud rising from the middle of the Pacific. Not for war, but for progress. The sky turns white, the ocean boils, and humanity watches, certain that it's building a better world. But physics doesn't care about good intentions. Energy that massive doesn't obey politics or hope. It only obeys laws. So let's find out what would happen if we tried to turn the most destructive weapon ever made into a tool for creation. It's 9 a.m. in New York. The sky suddenly flashes white. For a moment, it's brighter than the sun itself, so bright that shadows disappear and every window turns into a mirror. Then comes silence. A silence so heavy it feels like the air forgot how to move. Millions vanish in less than a second. No pain, no warning, just gone. This isn't science fiction. This is what happens when the laws of physics meet human ambition. The same ambition that once whispered, maybe we could use this power for good. After the atomic age began, some of the brightest minds in the world started to imagine the unthinkable. If one bomb could destroy a city, what could a few do to reshape the planet? What if we used nuclear explosions to dig canals, build harbors, stop volcanoes, or even calm hurricanes? The idea wasn't born out of madness, at least not at first. It was called geoengineering, using technology to control nature itself. The reasoning sounded simple. Nuclear energy had already shown it could move mountains, literally. So why not put it to work? But to understand how dangerous that thinking was, you first need to understand what a nuclear blast really is. When a nuclear weapon detonates, it's not like dynamite. It's not even like lightning. It's the sudden release of the energy locked inside atoms. The same kind of energy that powers the sun. A single bomb, like the one dropped on Hiroshima, released the energy of about 15,000 tons of TNT. A larger hydrogen bomb could unleash 50 million tons. That explosion doesn't just make a fireball. It makes a tiny, man-made star. The air around it heats up to tens of millions of degrees, hotter than the center of the sun. The ground melts, metal vaporizes. The light burns shadows permanently into walls. Within seconds, the surrounding air rushes outward faster than sound, flattening everything in its path. Half the bomb's energy becomes a shockwave, the invisible wall of air that crushes buildings and bones alike. Another third becomes heat, a flash so intense it can ignite skin and wood from miles away. The rest becomes radiation, the silent, invisible part that lingers long after the noise fades. And here's where the geoengineering dream falls apart. All that energy, all that destruction, comes and goes in less than a blink. Nature doesn't work that way. Oceans, storms, and volcanoes are systems that release energy gradually over days, weeks, or centuries. A nuke is a punch thrown at a planet that doesn't flinch. Still, during the Cold War, people believed the impossible. They thought they could turn nuclear weapons into tools. Not for war, but for progress. They gave it a name that sounded almost biblical: Project Plowshare, turning swords into plowshares. But before long, they would discover a truth written not in philosophy, but in fallout. You can't bargain with physics, and when you try, the planet always wins. In the next part, we'll see what happens when that dream was actually tested deep beneath the ocean, inside a hurricane, and within the heart of a volcano. Now, you lower a 50-megaton device into the Challenger Deep, 11,000 meters down, where the sea presses on you like a weight you can feel in your bones. When it goes off, the bomb does what bombs do. For an instant, a tiny patch of ocean becomes a furnace hotter than the surface of the sun. Water vaporizes and a vast bubble of superheated steam and gas tries to grow. But the planet pushes back. The crushing column of 11 kilometers of water keeps the bubble from blooming into the sky. It swells and collapses in a few violent pulses, each one slamming the surrounding water like a drum. At the surface, you do not get a single world-swallowing tsunami. Instead, you get a strange thermal hotspot, a plume of radioactive water and debris dragged up from the abyss. and a local ocean turned into a chemical and radiological soup. Life at depth is wiped out instantly. Creatures that evolved to survive under crushing pressure are not adapted to boiling and radiation. Tiny amphipods, slow-moving worms, and bizarre single-cell giants vanish. Over years and decades, the fission products sink, disperse, and enter deep food chains where they bioaccumulate in long-lived animals. The result is not neat. It is messy, slow, and impossible to clean. The ocean remembers. The heat pulse may spark local storms and slightly alter currents. But the biggest, longest-lasting damage is a spreading contamination that works its way through ecosystems on a timescale far longer than your lifetime. Next, imagine flying into a hurricane thinking you can fix it with a single blast. People once seriously proposed planting a bomb in the eye to break the storm apart. The thought makes sense at a glance. A big explosion seems like it should ruin a storm. But a hurricane is not a thing you can shatter. It is an engine that runs on warm sea surface and atmospheric flow. A mature hurricane releases energy continuously, and that continuous release easily overwhelms a single impulsive shove. Detonating a device inside the eye does not stop the engine. Instead, the explosion vaporizes the device, producing a plume of radioactive particles that the storm's circulation eagerly picks up and distributes. The winds and the rain that once only carried water now carry contamination inland and across states. You do not stop the hurricane, you turn it into a moving cloud of fallout. The area downwind suffers contamination of soil and water. Crops become unsafe, and communities far from the blast face invisible radiation risks. The problem compounds because the storm's natural mixing spreads the material over a huge area that is then hard to track or clean. Then picture placing a device on the flank of an active volcano to collapse a chamber or seal a vent. That was another serious idea, to tamp down a volcano with brute force. Volcanoes are under high pressure and are connected to deep, complex plumbing. Hitting that plumbing with a sudden violent shove is like punching a balloon full of pins. The shockwave will crack rock, not neatly seal it. New fractures can open, letting magma find fresh escape routes, and a pressure drop in one place can trigger a far larger eruption somewhere else. Worse, vaporized nuclear material mixes with volcanic ash and gas, lifting radioactive particles into the atmosphere on the same currents that distribute ash worldwide. What might have been a local eruption becomes a radiologically enhanced eruption with ash and aerosol that travel long distances. Rivers of hot pyroclastic flow become deadly conveyors of radiation. The short-term result is catastrophic local destruction. The long-term result is widespread contamination of soil, water, and air that can make whole regions unsafe and degrade agricultural lands for generations. Across all three cases, the pattern is the same. A nuclear blast is a single, brutal burst. Oceans, storms, and volcanoes are sprawling, persistent systems. You can add a colossal impulse to a slow-moving engine, but you cannot redesign that engine with one strike. The impulse may cause immediate damage, but it also grafts on a new hazard that lingers: radiation. The attempt to use the most violent tool humans possess as a precision instrument against nature ends up multiplying risk, creating contamination that lasts far beyond any intended benefit. In July 1946, the U.S. Navy gathered an armada of warships at Bikini Atoll in the Pacific. They weren't preparing for battle, they were testing how a nuclear weapon would behave underwater. The test was called Baker. The bomb itself was small by later standards, only 23 kilotons, but when it exploded just 90 feet below the surface, it turned a tranquil lagoon into a boiling, radioactive cauldron. A column of water nearly 2 kilometers high shot into the sky, carrying sand, coral, and pieces of warships with it. When that pillar collapsed, it sent out a dense rolling wall of mist called a base surge, a fog filled with radioactive droplets that coated every ship and every sailor within reach. The blast itself didn't sink the fleet. The invisible fallout did. The water of Bikini became a toxic soup of isotopes like cesium and strontium. Navy crews tried to scrub the ships clean, but nothing worked. Paint, steel, even wood absorbed the radiation, one by one. the vessels were scuttled in the lagoon. That was humanity's first true nuclear environmental disaster the moment we learned that radiation clings, seeps, and survives. The same base surge mechanism that spread fallout over those ships would repeat in any underwater or atmospheric blast. A hurricane hit by a bomb would become a radioactive storm. A volcanic eruption seeded with nuclear dust would spew glowing ash across continents. Baker proved that contamination isn't theory, it's a guarantee. And even Baker's 23 kilotons are nothing compared to nature's own fury. A modern hydrogen bomb releases around 50 megatons. The 1883 eruption of Krakatoa unleashed about 200. The Tunguska impact in Siberia hit with roughly 20. And the asteroid that ended the dinosaurs roughly 100 million megatons. The point is simple: what we call the ultimate weapon is still a flicker compared to the engines that already exist in nature. The difference is, nature doesn't need permission to fire. In the end, every attempt to tame nature with nuclear fire leads to the same realization: the planet is not an enemy you can defeat. It's a system you're part of, the experiments we imagined, and the ones we actually carried out. All reveal a single truth. Nuclear power is not a tool for precision. It's a shout in a universe that responds only to balance. From the scorched ships of Bikini Atoll to the theoretical blast beneath the Mariana Trench. The lesson is written in radiation and regret. We learned that contamination does not vanish. It migrates, multiplies, and waits. We learned that you can sink ships and cities, but you cannot erase fallout from the soil, the sea, or the bloodstream. Yet there's irony here. The same force that can destroy life in seconds also powers stars, fuels spacecraft, and treats cancer. The problem has never been the energy itself, it's the hands that use it. Radiation kills, but it also heals, illuminates, and reveals the structure of the universe. Maybe the question was never how to control it, but whether we should try at all. Because the moment you try to weaponize creation itself, creation will always fight back.